tracked queries, allow you to monitor specific high-impact statements in real time. Together, these metrics let you act like a performance detective, quickly pinpointing, diagnosing, and resolving the bottlenecks with data-driven clarity. Now let's talk about intelligent query processing. One of the SQL Server's smartest evolution. IQP allows SQL Server to enhance performance automatically with no need to change a single line or your code. It relies on adaptive algorithm and AI logic to adjust execution plans dynamically. Adaptive joins decide during a query execution whether to use a nested loop or hash join based on the number of rows written. It literally adapts mid-flight. Batch mode on row store brings the parallel efficiency of column store operation to traditional OLTP workloads, faster aggregation and filtering. Scalar UDF lining takes your user-defined function and transform them into inline code and removing context switching overhead. And table variable deferred compilation ensures that the optimizer uses a accurate row estimates, reducing poor plan selections caused by bad guesses. In short, IQP is like having an auto-tuning co-pilot sitting beside the DBA, constantly learning and optimizing execution plan in real time. So auto-tuning. Now that we have seen how SQL Server becomes intelligent with IQP, let's see how it becomes self-correcting with auto-tuning. Auto-tuning is like SQL Server's own immune system. It keeps track of all query plans over time using the query store. And if a new plan causes lower performance, SQL Server automatically reverts to the previously known good plan. No DBA intervention needed. So here what happened behind the scenes. Query store capture execution stats of every query and plan. The auto-tuning engine detects a regression, meaning the new plan takes more CPU or duration than the old one. SQL Server flagged it. Test and the old plan again, and it's proven better, it automatically forces it. Thinking of it like a self-driving car that learns from every mistake and corrects itself without waiting for a mechanic. This feature is especially powerful in production system where query patterns change often. You get a consistent, predictable performance experience even when workloads evolve. So now we'll dive into a demo session. So in this demo, we are going to enable query store and IQP and then auto tuning. So combining together, we are going to so here we are combining together. Now we are enabling a query store. Okay, now query store has been successfully enabled. Then as operation mode as a read write, and then query capture mode for all the things. So and then we are giving interval length minutes as every 1 minute. Now I'm creating a table in a AI demo DB. Now I'm inserting around 2 lakhs of data because it's a lab environment. So I just want to show as a production things. That's why I'm creating insertion, random insertion in as a 2 lakhs of data here. So it might take time. So in that we can see a features of query store. So these are the query store features. And the main things or components are regress query and overall resource consumption and top resource consuming queries. So first we can see top resource consuming queries. So here's the lab system. So not a production. Overall, it's not able use. So here it could be good and able to see more of traffic here. So I'm so as of now we are executing the insertion query. So here it is captured here. And now we can see overall resource consumption. So on these things, if it is in a production environment, we can see several things. So how many, if the queries are running, kind of XYZ queries are running, we can see the duration here and then execution count and CPU time and logical reads here and regressed queries. So it will be very much helpful if while doing an index rebuild or updates to Excel kind of things. So this will show how many queries are running in a second during if the performance is slow or things. So it will be very much helpful. Now our insertion query has been, let's say, now the data has been inserted. So here I'm running a query with a good plan. So here I'm giving us a 10 because it needs to be executed 10 times because we didn't have any loads as of now. That's why I given 10 times. So somewhat loads will be there. Now we are checking whether plans are captured or let us see in GUI first. So here our plan ID is 33. Sorry. Here our plan ID is 47. Now we can see here at the top 10 queries which are captured here by the query store. Here is our ID. So for creating a plan, I'm dropping an index. And again, I'm executing the same query. Okay. Post that was enabling the IQP. I'm running the query again for creating the loads. Now I'm enabling auto tuning. Auto tuning is nothing but it will take automatically, it will take the good plan. So I have enabled auto tuning here. Now I'm running this query several times. So here, if you go and see here, Am I audible? Okay, here you can see the 47 is in not forced, so it is not taken. Let's see whether we'll see whether automatic tunic is enabled or not. So now we can see I have enabled after this. I have executed multiple times, and now you can see the forced plan is the plan is forced auto enabled by auto tuning. So you can see now the plan ID has been captured as a forced plan. So you can ask what is forced plan and unforced plan. In a query store, a forced plan is nothing but equal automatic SQL Server automatically. SQL Server automatically tells SQL always use the specific execution plan for this query. It worked well earlier like that. So if unforced plan is when SQL is free to pick whichever plan it think it's best, so it will take automatically. So now we are not do anything manually. After we have implemented enabling auto tuning, so it will the SQL itself auto tuning itself take a good plan as a first one. So if we are executing multiple plans and it is creating multiple plans, so like a plan A or plan B, if a plan A is a good and plan B is a bad one, and then we have enabled auto tuning, then it will take a plan A. So after executing other so many after execution, so maybe a plan C will more good compared to plan A. So that I'm auto tuning automatically for unforced plan A and it is forced to plan C. So it will automatically tune. So where it will in a real time, you can ask where it will be useful in our real time. So when a say example like a Zomato company is taking every day, they are fetching an order reports and every morning. So sometimes it will take two minutes, sometimes it will take uh, 2 seconds or something. So one day it will take around 10 minutes or more than 15 minutes. Then they will question us why it is more running more than this things. So if we are enable these things, so then we can tell them. So this is the thing, and query plan automatically it will trigger this, so we can avoid the those performance issues. So now we can see now we can see where AI fits in. When we say AI in SQL Server, we are talking about the blend of adaptivity, learning, and automation, not here as a chatbot or robot. So in this 2019 version, it is taking a mix of together as a query store and then IQP and auto tuning. So here AI is act as a adaptive learning and automation. Just like how human DBA learns from experience, SQL Server internal intelligence uses machine learning models to detect regressions, meaning it understands when performance goes down and why. It studies execution patterns and from the query store predicts potential regression and then automatically applies tuning actions. That's where auto tuning shines. The new generation SQL Server 2025 takes it further with SQL Pilot and vector search. And now let's talk about the star of the show, SQL Server 2025, where AI and data management truly emerge. Microsoft has taken all the lessons from Query Store, IQP, and auto tuning and powered them with AI intelligence and OpenAI models. Vector search is one of the biggest leaps. It lets SQL Server store and query embeddings, which are numerical representation of meaning. Imagine searching your product catalog not just by name, but by similarity in meaning. For example, asking SQL, show me items similar to wireless earphones. Behind the scene, AI understand the context and similarity, and not just keywords. Next, AI Copilot in SSMS, like having a senior DBA beside you. You can type, why is my query running slow? And Copilot will query, analyze query store data and suggest index and even rewrite parts of your SQL automatically. Integration with Azure OpenAI means you can connect directly to models like GPT for generation insights, reports, or even intelligent code. IQPv4 makes SQL Server smarter. It learns how your data changes and keeps your query plans adaptive over time. Automatic index and stat maintenance means no more manual midnight jobs. The system identifies state statistics and rebuilds or update index automatically. And finally, AI-driven diagnostics. SQL now detects performance anomalies in real time and notifies you before an alert even fires. In short, SQL Server 2025 is not just managing a data, it is managing itself. So now we'll see how to enable Copilot in SSMS 2025. Okay. So you can see now I have enabled Copilot here. So let me tell how to enable a Copilot. If firstly we have to install SQL Server 2025 and along with it SQL SSMS 2021 with VS Code, Visual Studio. So if after enabling this, after configuring SQL Server and SSMS, if you are clicking a Copilot, it will shows like this. So we need to give an Azure OpenAI endpoint and Azure OpenAI deployment, Azure OpenAI API key. Let me tell you how to fetch these things. And for enabling Copilot in SQL Server 2025, we need a Azure portal login. Without Azure portal login, we couldn't able to access Copilot. So in Home, already I have created a thing. So let me show you how to create a new endpoint keys. So here I'm giving a create and Azure OpenAI. So here it will ask a subscription key for resource group. So we need to create a resource group. So here we can give like And here we can give like Azure. Yeah. And here I'm giving standard S0. After this, we can give next. Yeah. Now, here we are giving all networks, including the internet. Sorry. So here I'm giving all networks, including the internet, can access this resource. So if we are using any VPNs or anything, so we can give according to it. So here I'm not using any VPN, so I am giving here, and we had given next. So then it will create automatically. So already have created. So I'm just using this. Suppose that you will get the resource here. Now we can give keys and endpoint. So you just create the copy of the endpoint and paste it on this field. And then just take a key and paste it on this field, Azure Open API key. Suppose that we need to take a then we have to deploy a OpenAI deployment. So here we are going overview. I'm giving explore AI boundary. Then deployments. And here we already have created a GPT-4.0. So if you want to create, give a deployment based model, and then you can give whatever the things you need. So here I have used GPT-4.0. Then if you give a confirm, then it will create accordingly. So now I have already created. So I'm canceling it. So post it creation, you will get things here. Then give it things, and then take a deployment name as GPT-4.0 and paste it here. After doing all those things, Copilot will be enabled. Post this, you can ask a question like, here I'm connecting Adventure Books 2022. So here I'm asking on this is or in this TV. So here it is telling there are 71 tables in the current database. Now we'll cross verify it. So we not worry. So here's another one. So kind of things we can ask it to generate a report. So these kind of things we can ask Pilot. So it will we can ask top 10 tables based on the size. So here we can easily access the SQL Server 2025 on our own on our own language. So we don't want to know the queries. So it will be very useful for freshers to access easily and the developers. So here are the list of the tables. So here are the pros and cons. So in room AI-driven optimization, SQL Server takes over a lot of repetitive tuning work. For example, instead of a DBA manually identifying which query got stored after deployment, SQL Server itself detects that using query store intelligence. It automatically rollbacks to the last known good plan, which means less downtime and faster recovery. Over time, the engine learns your workload patterns and predicts what plans will work best and applies those automatically. So it's like having a virtual copilot continuously optimizing your database in the background. And cons now, as this with any intelligent system, there are trade-offs. For instance, sometimes SQL Server might force a plan that worked well earlier, but due to data growth or schema changes, it may be no longer be the best fit. That's why continuous monitoring is essential. Also, since Query Store collects a lot of performance data, query text, plans, runtime stats, there is a slight overhead in CPU and storage. It's small but noticeable and high throughout systems. Another key point is that AI and auto tuning depend on accurate statistics. If your statistics are outdated, the model's recommendations might not be optimal. Finally, one of the biggest challenges is transparency. While AI is doing great behind the scenes, as DBAs, we often don't get fully visibility into why a specific plan was chosen or forced, which means we still need human insight to essence. So, in meanwhile, you can ask. So, whether we are installing AI or Copilot in SSMS, so we can ask about the data security. So, the first concerns that comes into our mind is data security, right? So, Microsoft has designed SQL Copilot to work within your organization security framework. If you are using it locally within SSMS 2025, it operates only on your environment. Your queries and data are not shared outside your network unless you are explicitly connect to an Azure AI service. Even when you use Azure OpenAI integration, data is protected through encryption at rest and in transit. And Microsoft Responsible AI framework ensure your data is not used to retrain or expose models. Additionally, RBAC and auditing policies still apply. So many AI assisted query tuning or recommendation are logged and can be monitored. In short, Copilot enhance intelligence, not risk. You are still in full control of your data and environment. So here are the wrap up and key takeaways. So here we see a query store, brain of performance tuning, which is like a black box in an airplane. And IQP has smart query execution. So if we are using any map, Google Map on travel, so if IQP is enabled, it will help like a correct uh, route without traffic, and we can reach our destination years early. So, and auto tuning, a self-healing engine, so it will shows the good plan. And SQL Server 2025 brings AI inside the engine, and Copilot, your AI DBA partner, and future autonomous SQL Server with human oversight. Thank you for attending.
Yeah, thank you, Divya, for providing a comprehensive overview on how it looks when AI meets DBA. Okay, now we are at the end of the webinar. Now we'll be having a quick Q&A sessions. If anybody have any queries, you can ask Divya and feel free to ask questions. Anybody?
Hi Divya, am I
Yeah, hi
audible?
Navraj. Yeah,
Yeah,
yeah.
yeah. So first of all, I like to thank you for the session. I had a the thing is the first you mentioned the query store. It captures all the query plans, right? So the how
Yes.
the it means like it will capture all the query plan. If the query is running repeatedly for 1,000 times, for example, the 1,000 times it will capture the explain plan how it actually works, how the storage in that case there are so many queries will run, then so many plans will repeatedly comes. How this storage is actually handled in this case actually?
Yeah. So there is some more features on query store. So it will store all the query plans like a memory. So whatever thing is coming, it will all store. So if you are if you are afraid of the disk drive space, so we can enable 1 month. We can clear it 1 month once. So on that part, it will be retention. Auto retention is there, and you can also write. So here in this demo I have given one every 1 minute. So on this part you can give like 5 minutes, or based on your production and traffic, so you can give accordingly. So
Okay. Got it. Thank you. And one more thing
yeah.
is for tuning slow queries optimization, since it is integrated with this AI feature, so when we manually check for the plan, when plan of how, for example, for optimize the slow queries, when we while we checking the slow queries plan,
Mm.
what it will show? Then it will show the best plan, or how it will work actually in that case actually.
So if we enable a auto tuning, so if you are executing the query, same query again and again, so automatically it will unforce the old plan. If you have created a new one, like you have dropped something like based on the based on the stats, machine learn model was enabled, and it will be deciding on the store execution plan.
Okay. Thank you.
Yeah, yeah, Nagaraj.
Anybody else? Okay, we would like to wind up for today's session. Thank you everybody for joining. We will be posting the highlights of today's webinar on our YouTube channel, and also keep follow us on LinkedIn so that you will be updated on the future and new webinars also. Thank you everyone and have a great day.